segment. All right, so let's look at the implicit differentiation worksheet, number 8, because we forgot what a chord is. A chord is just a line segment that connects 2 points from geometry long ago. Y squared equals 4 plus x. The chord AB joining negative 4, 0 and 0, 2. So I'm thinking they gave me 2 points. We're talking about a chord. There may be some slope something coming. That's my guess, because slope and derivative go together. Find the xy coordinates of the point on the curve where the tangent line is parallel to the chord. Similar to one of those on the last test, there was a parallel question, which most of you got. I mean, it's the same slope. A few people, because the example I did in class had perpendicular, so a few people found the perpendicular slope because that's what we did in class. They didn't, I guess, read the question carefully enough. So parallel to the chord. So good old Algebra 1 slope. 2 minus 0, that 2 and 0, over, make sure we get these in the right order, so 2 minus 0 over 0 minus negative 4. So 2 over 4 is 1/2. Find the x and y coordinates of the point where the tangent line is parallel to the chord. Okay, so I need to know, basically it's asking me where is dy dx equal to 1/2. So 2y dy dx equals 1. So dy dx equals 1 over 2y. That's the slope of the tangent line to this graph. But that also needs to equal 1/2. So 1 over 2y equals 1/2. Well, we could do some algebra on that, or hopefully you could just look at that and figure out, well, the only way that's going to work is if y is 1. Right? I mean, I guess you could cross multiply, divide by 2. Yeah, y is 1. Check my question again. Find the x and y coordinates. Okay, so I got y. How am I going to figure out what x is? Plug it back in. Y squared equals 4 plus x. But now we know that y is 1. So x equals negative 3. So the point we're concerned about, or the point on the graph whose tangent line is parallel to 1/2, is at negative 3, 1. What's that? Zoom out so you can see the whole thing. Big picture.
What is the chord thing?
What is the what?
When it says the chord.
Chord is just a line segment that connects those 2 points.
Isn't that like on a circle?
Circles have chords. Is a connection between any 2 points on the circle. Yeah. So. What's that? No, it does not ask for the tangent line.
Wait.
It just says find the x and y coordinates. So that's one where if you did more, you'd still be okay as long as negative 3, 1 was on your paper somewhere. And if you went further,
Equation and everything. But I guess that would show the
it would, as long as your point was on there somewhere. If you went further, you'd be okay. And I think this is part of why AP graders, and I don't make a big deal out of this because I like boxing things, but AP graders say don't box stuff.
Yeah.
Because it commits you to that answer. And if you don't box it, well then if your answer is on the page, I'll find it.
Well, what if your
As long as it's
work is
labeled.
so bad that you can't find it? Well, I'll get that. But then do it.
That's the show your work neatly.
You'll have fun searching for stuff. It's
Well,
a treasure
AP
hunt.
graders, like if your work is like really messy or it's
Partial
If it's messy, I mean, if they can't read it, no, they'll try. But if you magically come up with the right answer and your work doesn't support your answer, you won't get points for it. And I do that in pre-cal. I mean, I'll say it. I don't think my calculus person does this, but sometimes pre-cal people do it. They end up with the right answer. It's like very fishy if it's an online person does that. It's like, how did they get that? I don't want to make accusations, but I don't know. So I'll just say no credit because the work doesn't support your answer. So I don't want to accuse you of anything, but it certainly crosses my mind if you end up with the right answer and nothing that leads me to or leads you to that answer. Number 10. Find dy dx and then find all the points on the curve whose x-coordinate is 1. Write an equation for the tangent line to the curve at these points, and then where the tangent line is vertical. All right. Product rule. Can I product rule in place yet, or you want me to write out f and g? I'll split the middle with you. I'll label f and g and then do it in place. So the first one is x. The derivative of the second one is 2y dy dx. Plus, the other way around, the second one is y squared, and the derivative of the first one is x. It is.
Oh, okay. Yeah. Okay.
And then same, I mean not exactly the same, but same process. Minus sign, I'm going to put the minus sign out front just so I don't have to worry about it. I'll distribute it later. And again, product rule in place. Hopefully you're kind of getting to the point where on ones that are simple enough you can pull that off. So first one, x cubed, derivative of the second one, dy dx, plus vice versa. So the second one is y. The derivative of the first one is 3x squared. And then not equals 6, but equals 0, because the derivative of 6 is 0. Okay, speaking of not showing work here, anything without a dy dx needs to go to the other side. So negative y squared minus 3x squared y. And we're going to factor out a dy dx from what's left. So that would be 2xy minus x cubed.
Would that be plus 3x squared y because of negative?
It sure would. That's what happens when you skip too many algebra steps at once. Yep. The minus sign would distribute, and then we would add it to the other side. And now I probably should have wrote it the other way, so it'd be a subtraction, but whatever. So dy dx equals, I'm going to switch it up here, 3x squared y minus y squared all over 2xy minus x cubed. That was part A. A little bit of calculus, a little bit of algebra. Not too bad on either one, really. Find all points on the curve whose x-coordinate is 1. So 1y squared minus 1y. Oh, I see what's happening. I'm going to move the 6 over. And I've got a factoring problem. So y minus 3 and y plus 2. So the point 1, 3 and the point negative 2, whoops, 1, negative 2. Where x is 1, there's 2 values for y. Find all points on the curve whose x-coordinate is 1. Got that. Write an equation for the tangent line to the curve at each of these points. Oh, come on. Who made this worksheet? So I need dy dx at both of those points, and then I can write the equation of the line. I'm going to be lazy and only do one of them. So dy dx at 1, 3. So I'll look at dy dx, plug in 1 for x and 3 for y. Carefully. And I guess if I was feeling lazy, I could leave it like that. It'd be accurate. Let's see. Oh, this is good. What's the numerator become? 9 minus 9. 0, and that means the bottom doesn't matter as long as it's not 0. 6 minus 1 is 5. So my slope is 0. I'm kind of glad this happened. What's going on? What does that mean? What does that line look like? What's the equation of a line that looks like that? Y equals 3. Now the good news is if you did write it the other way, y minus 3 equals 0 times x minus 1, that would be correct. It's a little bit of a odd way to write just a simple horizontal line, but it's not wrong. So if you really just kind of weren't paying attention and you were just kind of following the formula of plug in the point, plug in the slope, be all right. Find the x-coordinate of each point on the curve where the tangent line is vertical. Again, I skipped finding the tangent line at this point because it's the same process. Just because I didn't want to take the time to do it. So yes, officially you should find both of them. What is a vertical tangent line? What's it look like? No. No is actually not a bad answer. It looks like this. When you say no, what do you mean no? It's not differentiable. Okay. But I already have a derivative. How about, let me ask it this way. What's the slope of a vertical tangent line? Undefined. I have to think backwards here. What would make my derivative be undefined? 0 in the bottom. So undefined, when denominator equals 0, so I'm going to go just grab the denominator and set him equal to 0. And then I don't know if I can do anything, but I could factor out an x. That would leave 2y minus x squared equals 0. So the first part's easy. So at x equals 0, that would be a vertical tangent line. And this other part, I don't know about that. That would take some more work. But it just said find the x-coordinate of each point on the curve where the tangent line is vertical. So let's go with x equals 0.
So you don't need to find the other one?
The problem with the other one is, let's see, x squared equals 2y. So x equals plus or minus the square root of 2y. That's not really a point, and there's no way to solve for. I'm stuck on that part. What I am glad you asked after looking at the test yesterday is this part of this problem. Finding a vertical tangent line. Vertical tangent line, slope undefined. That happens when the denominator is 0. That you definitely need to know.